Hi, today we're going to talk about the various software development lifecycle methods and models that exist. And this is part two of the unit three. Um, so let's talk about some SDLC methods. Like we discussed in the previous part, uh, you need a SDLC model to guide your software development lifecycle and software development project. And with this help, you can actually identify very well uh, for your requirements, for your criticality, for the kind of developers that you have, which model will work the best so that you do not have to, you get the highest quality productive work possible, right? So let's start with the most obvious code and fix model. So this model starts with an informal general product idea and just develops code until a product is ready or money or time runs out. Work is in random order, right? Basically, it's hacking. This is This is exactly hacking, nothing else. It corresponds with no plan. What are the advantages? There are no administrative overhead, signs of progress early, you can quickly show something, low expertise needed, anybody can use it, and useful for small proof of concept projects. Example as part of risk reduction. You just want to quickly code something and see whether it works, go for it. What are the limitations? Well, it is very, very dangerous, right? It's dangerous for most projects. Okay, there's no way to assess progress, quality, or risks. Unlikely to accommodate changes without a major design overhaul because it has been just put together. Unclear delivery features, that's scope, timing, and support, right? And it's impossible for large projects. Communication breakdown, chaos, too many things can happen, right? The next is very, very popular, which is waterfall method. In the waterfall method, essentially you go through a certain sequence. Okay, you go through a certain sequence of steps through which a product is developed. Okay, so if you can see here, the user requirements are gathered. What is the output of this phase? You get a user requirements document. Then the software requirements are understood from this user requirements, which leads to software requirements document. Then comes the architecture design, that what is the architecture that we need to build to support the software requirements. You get a architectural design document. Then you come to a detailed design and coding, which is leads to a good amount of coding and design. And then finally, you get to testing stage and then you deliver the product. But as you can see, as the time goes to the right, these requirements keep coming in, and finally they exactly happen in this sequence, right? And this is swimming upstream. If you swim upstream, this is how uh, things move, right? Now, as you can imagine, this is not a too bad model. Just that what started happening was when internet came in, that is in 1994, 95, it became just easier and easier to actually ship product and deliver it online. Earlier, softwares used to be delivered in CDs, and the cost of sending the CDs and everything was way high. And that is why you had to follow a certain waterfall method, because it was not very easy to actually get some testing or some results out. Correct? And that is why people followed a certain waterfall method model, because you just cannot. You need a very well defined, non-buggy software to be sent out to the market, because the cost of just getting the software back would be very, very high, right? Or delivering a patch will be very high. So you better be very, very clear, very accurate. And that is why waterfall model works very well when you have specific requirements, right? But in the new age, it is considered that waterfall model is idealized. It doesn't match reality very well, because the requirements keep changing. The user requirements are not static as waterfall model assumes, because everything starts from user requirements, and if the user requirements itself are changing so frequently, then the stuff that will be delivered will also be not so good. And in fact, if you look at, if you can relate this with how agile or how modern software development is done, you can actually see that each sprint cycle is actually a miniature waterfall model. right? It's a miniaturized waterfall. It's a small waterfall instead of a very large waterfall, right? So we are still using it in some form, but just that is not used in the traditional sense, right? So just to conclude, so waterfall model is typically now considered idealized and doesn't match reality very well. It doesn't reflect iterative nature of exploratory development. Development is very exploratory in nature. You throw up on a certain problem and people will develop it. So it works very well when everything that you want to build is already laid out. It doesn't work very well, when it's all exploratory. It's unrealistic to expect accurate requirements so early in project. As I was saying, getting the accurate user requirements in very early stage is very, very difficult, and that's why most of the software projects get delayed, right? Because earlier requirements were very different. By the time the software was delivered after 3 months, the requirements have changed. So you need to patch up, correct? The software is delivered very late in project, which delays discovery of serious errors. If there are issues later on in the delivery, tough luck, right? So it's very difficult to integrate risk management. It's very difficult and expensive to make changes to documents while you're swimming upstream, right? And significant administrative overhead, and that's why it's very costly for small teams and projects. And that is another reason why agile, the other, which is considered now the hero, and where waterfall is considered the villain. That is why agile methodology got so much of prominence, because the startups which started coming in with the advent of internet, all the internet startups, uh, people needed lesser and smaller teams to build products and build softwares, right? And that is why waterfall was shunned, because one, it didn't lend quick software delivery, and two, uh, it also works better for larger teams. For the smaller teams, it's just too much of work. It's just too much of administrative overhead. People just want to build something and ship it up and ship out, right? The next is a spiral model. You might not have heard of it, but it's actually used. It's very commonsensical, right? Since end user requirements are hard to obtain, like we just mentioned in waterfall, the end user requirements are hard to obtain or define. It is natural to develop software in an experimental way. That is, build some software, see if it meets customer requirements, and if not, go to step one, else stop. Correct? So this loop approach gives rise to structured iterative lifecycle models. So in 1988, Boehm developed the spiral model as an iterative model which includes risk analysis and risk management. So key idea is, on each iteration, identify and solve the sub problems with the highest risk. So what's the riskiest assumption, or what's the riskiest problem that you're facing right now? Sounds very commonsensical, right? And I believe a lot of the concepts of agile methodology is based on spiral model. I believe so, right? So each cycle follows a waterfall model by determining objectives, specifying constraints, generating alternatives, identifying risk, resolving risk, developing next level product, and planning the next cycle. So this is a cycle in which it goes. And if you will see very soon that waterfall is actually present in most of the models. Just that the scope of the waterfall, that how much requirement are we going to gather, reduces, and which also leads to a reduction in the length of the entire project. So imagine if you're gathering a lot of user requirements, which requires about 6 months or 1 year of coding, you will get a very large waterfall model, which actually makes it very, very difficult to stay true to the original user requirement. Correct? And as you start reducing the scope of user requirements, that how much are you going to gather right now and what you're going to build right now, um, the scope reduces. So obviously the time taken to finish the project also reduces. So the waterfall still stays, but just that it is because of the nature of uh, uh, the user requirements which keep changing, you can now be much more uh, relevant to what user wanted, right? So what are the benefits of spiral model? Well, realism. The model accurately reflects the iterative nature of software development on projects with unclear requirements, right? So if the requirements are very clearly unclear, don't use waterfall in the traditional sense. um, Another benefit of spiral model is it's very flexible. It incorporates the advantages of the waterfall and rapid prototyping methods. It's comprehensive model and it decreases risk and it gives you good project visibility. What are the limitations? Well, it needs technical expertise and risk analysis to really work, right? You need to really understand what's risky, both in terms of business, in terms of software, in terms of everything. The model is poorly understood by non-technical management as well, so that's why it's not very widely used. And it's a complicated model. It requires competent professional management, high administrative overhead, because you need to do risk analysis and then you have to move ahead, then risk analysis, then you have to move ahead. It's costly thing. The next is staged delivery model, right? So there's a software concept, you do requirements analysis, you do architectural design, very similar to what Waterfall has, and then you stage one, you have a detailed design code, debug, test, and delivery. Then stage two, then stage N. So you have basically instead of Waterfall, where there was a one single product which was released, it starts very well, very similar to what Waterfall is, how Waterfall starts, but instead of one single large delivery, it breaks down the delivery into multiple stages. That's why short release cycles, right? What are the benefits? You end up shipping at the end of any release cycle, so it looks like success to customers or to stakeholders. Intermediate deliveries show progress, satisfy customers, lead to feedback. Problems are visible very early because you are able to ship something working early on, and that's why it's very practical and is widely used and it's successful also. What are the limitations? You need tight coordination with documentation management and marketing because you're releasing very frequently. Products must be decomposable, that is, you can actually deliver something, you can actually have a product in three different stages in the sense, and each of the stage can release something working, right? And extra releases also can cause overhead, right? Then comes a very interesting one, which is called evolutionary prototype model. So you capture the requirements, you quickly design it, you build a prototype, you simply give it to the customers, you iterate till you have something very, very good with the prototype itself, and then finally engineer the final product. Right. So the basically the rapid prototyping model emphasizes requirements analysis and validation. So also called customer oriented development or evolutionary prototyping. So this again sounds very similar to agile, right? Um, what is the key idea here? The key idea is that customers are non-technical, okay, and usually don't know what they want and can have. That's why you quickly build something, give it to them, see how they use it, whether they're saying yes or no or whatever, and then you build it again, right? So what are the benefits of this? Well, it reduces the risk of incorrect user requirements, right? Because the customer doesn't know exactly what he wants. If you give him something, he'll be able to exactly tell you that no, this is not what I want. No, this is not what I want. Oh yeah, this looks useful, and so on. So you can build something which accurately reflects what the user wants. It's good where requirements are changing and are uncommitted. It regularly, and because of the regular visibility, it aids in management overall, right? And supports early product marketing because now you have prototypes. So prototypes are getting ready, and that is why the marketing team now has a better sense of what exactly is coming out, and so they can prepare much better, right? Um, what are the disadvantages or the possibilities here? Well, an unstable or badly implemented prototype becomes a final product a lot of times. It requires extensive customer collaboration, so it costs customers money. It needs committed customers. Customers should be willing to actually spend so much of time with you, right? And that's why some of the modern startups actually work in close collaboration with customers, and they give out freebies and a lot of stuff to woo these customers, and so that they build the right stuff for them. Right? It's very difficult to finish if customer withdraws, right? If the customer or the customer set of customers that you were initially working with, if they withdraw, then it becomes very difficult to finish because then you have to work with somebody else. And if the customer is too specific, or the way you have selected the customer base is too specific, there's a good chance that there's no broad market, right? um, right? And it's very difficult to know how long project will last because you're just going through the iteration. So where do you stop? Where do you stop? Where do you draw the line, right? And it's very easy to fix, as you can imagine, right? So it's very easy to fall back into the code and fix model, right? Where you're just going through the loop, and you're just without proper documentation or requirement analysis, you're just going through because you are under the impression now, or with the opinion that it's okay, we'll just send it to the customer and we'll see what they want. That is not how it works, because it will either that will irritate the customer, or you will end up building something purely out of fancy, right? So you need to have user requirement analysis, you need to have design, and then you need to get the customers to evaluate your product. The next is agile manifesto, or the extreme programming manifesto. Well, this I would say is the most popular one, especially popularized by a lot of technology startups, or software startups. um, well, agile manifesto emphasizes that we should um, it emphasizes individuals and interactions over processes and tools. So what started happening in 90s was that there are too many processes and tools which were getting introduced, okay, to manage software engineers and the entire software lifecycle, because the cost was pretty high and everybody wants to control such costly processes, right? But and a lot of developers and techies got really frustrated, and that's why they just came together to build this manifesto that, yeah, individuals and interactions matters much more than processes and tools. So don't just keep adding processes and tools to in the hopes that it will improve the productivity. It will not. Second, working software over documentation. A lot of companies at that time used to stress too much on documentation. So developers might end up spending half of their entire month, or half of their entire productive time just writing documentation. Documentation is good. I'm not denying that. And that is exactly what Agile also says. But it just also emphasizes that let's emphasize on working software. Let's get the software out, and then we'll add the documentation or create the documentation. Then customer collaboration is much more important over contract negotiation. Well, just to give you a context here, contract negotiation is a term that is used in enterprise setting. And when Agile Manifesto came in at that time, a good chunk of software that was built was for enterprises, right? And that's why the this term and this phrase is there. So customer collaboration is way more important. We should be able to talk to the customer, understand his requirements or gauge his requirements, and then build something. And finally, responding to change is way more important than following a regular plan, because user requirements will keep changing, things will keep changing. So we need to have a we should be able to proactively change or reactively change our plan of action instead of following a certain plan, right? So this has led to continuous delivery of software because you are able to ship things really well. Continuous collaboration with customers, continuous update according to changes. It value participants and their interaction. It focuses on simplicity in code and satisfy the specs, right? So what are the benefits of this? It reduces the risk of incorrect user requirements because you are able to go back to the users and get the right data and right requirements. It's good where requirements are changing or uncommitted, but when the requirements are already fixed in time, that yeah, this is our legacy software and we want to update it to a latest tech stack. The requirements are exactly set in stone, correct? In that case, agile might not be the best model to use. uh, and regular visible progress aids in management because everybody knows what is happening and what features are being shipped. It supports early product marketing again because you have something shippable, something workable early on, and so the marketing team can actually know what to use and what to market, right? This and similar to agile methodology, this also suffers with the same problem where um, well, a badly implemented prototype can become a final product or final delivery, right? So the other limitations are it is difficult to scale up to large projects where documentation is essential because agile doesn't emphasize too much on documentation. It needs experience and skill, if not to degenerate into code and fix, because there's a high chance, like the spiral one and the evolutionary prototype. There's a good chance that you might end up in a loop where you're just coding and fixing instead of actually spending time in figuring out the right requirements and doing and applying your mind. And it also suggests or recommends programming pairs. So people should be programming in pairs, and programming pairs is costly, right? And also, test case construction is a difficult and specialized skill, and especially in agile, right? Next comes Kanban. Well, Kanban is slightly different. So Kanban is not exactly a software development life cycle, okay, life cycle model. It's not SDLC. Agile is, Spiral is, evolution prototype model is, but Kanban is not purely a software development lifecycle model. It's more of a project management tool. Okay, and it originated at Toyota. Okay, they wanted a method. So they were trying to figure out at the assembly lines of Toyota that how can we get just the right quantity of spare parts needed to make the car at the assembly line, because if you get too many, that is a problem. If you get too less, that's a problem, right? So that is why they came up with this idea of Kanban, which was a visual board which allowed to see exactly the progress of the entire supply chain. Okay, so that's why Kanban, when used um, in that format, where you have a set requirements or you have a set plan that yeah you want these features or these functions to be produced, and you just want to manage the project delivery, that these 10 items or these 15 items needs to be shipped from here to the final production. So Kanban is useful there for the delivery thing. Okay, so it's based on three basic principles. Visualize what you do today, which is the workflow. Limit the amount of work in progress. So you should not be producing, or you should not continuously be shipping out. For example, let me take you back to the car manufacturing example. So there's an assembly line which is producing cars. Now go back 60, 70 years back, where cars were completely bolted together by humans. At that time, let's say one of the tasks is of some other team is to bring doors, pick doors from warehouse one and bring it to the assembly line port one, let's say. uh, Now let's say when the port one workers who are bolting together the cars, they face some problem, and because of that they're just not able to bolt the car door properly, and the work is just not moving. What will end up happening is, because of this delay, um, the team which was bringing the car doors will keep on bringing the car doors, and there will be a lot of car doors just next to the assembly line. Correct. So what you want to do is, if instead of this, let's say there was a limitation on the amount of work in progress, which is how many car doors can be present next to the supply chain, or next to the, sorry, assembly line. Let's say it was 10. So the team will stop uh, when the number of car doors next to the assembly line is 10. The team which was bringing the car doors will stop, and they will actually invest time in figuring out that why are these car doors not getting consumed. And so hopefully they will help in solving the problem, and then the workflow will again resume. And it also enhances flow. The Kanban is based on a simple principle of enhancing the flow. So when something is finished, the next highest thing from the backlog is pulled into play, right? That is how it works. So what are the benefits? It's a very lightweight model. It suits small to mid-sized projects. It produces good team cohesion because you essentially have produced a bunch of items that you want to solve, and you prioritize them from top to bottom. And the team simply starts picking up what is the top priority item. Just pick that, start working on it. Once you're done, put it on the next one. And because it's visual, it becomes very easy for anyone to quickly see a virtual or a physical dashboard or whiteboard, and know where the team stands right now, how many in progress and how many items are done. Next in line is within the Kanban there's few limitations. Okay, communication problem when there are multiple people working on the same story or same task, right? As you can see here, uh, there's a customer who is producing ideas. These ideas are then groomed into Kanban queue, which is prioritized from top to bottom. So this prioritization, everything happens via between product managers and the customers and developers at times. And this is the input stream. From this, the top item is picked up and put in the analysis. Let's assume that this is a work in progress. This is a work in progress limit, and it is put into the entire process, right? You can see green is the change request, orange is the defect, and yellow is the maintenance task. So analysis, then the design, then you develop, and then you test, and then you do UAT, and then you finally deploy. This could be the five stages of building something, correct? And that is another beauty of Kanban actually, that you can add as many layers or as many steps as you want, right? And then finally some of these products are then done, and this is where you archive, correct? um, so as you can imagine, working on a single story, there's a if there are too many people working the same story, it becomes very difficult to communicate. And because, as I said earlier, it's not exactly a software development life cycle, right? It's much more of a project management tool or approach. And that is why there is no defined delivery time, because it was not designed actually for project delivery. It was designed for keeping a assembly line moving. So assembly line should be continuously moving. That's it. That is what it was designed for, right? So it is not flexible for product mix changes, and it doesn't work very well for stable priorities, right? If priorities are exactly stable, that this is exactly what we want, then it kind of fails off. But if priorities are changing, so what I mean by that is, let's say enough tasks were pulled into the system that work in progress has hit, and so people are working on all the tasks that are already in the from backlog. They are in the to do list already. Now, let's say the priorities have changed, right? So what will that lead to is it will move uh, the sequence of the tasks in the backlog, correct? And if the priorities are absolutely stable, then you do not really have to use this, correct? Then comes the very interesting one, especially most, I would say, pragmatic of all, especially in today's day and age, is commercial of the shelf software, right? So what you'll do is basically you will just engineer together a solution from existing commercial software or open source packages or whatever to build a minimal software glue. Basically, just get a database, get something, put them together, and you have a software which will just work fine for the requirements. Um, Nowadays, the quality of the software which are available individually has increased a lot. They've improved a lot. And that is why a lot of times this is not just patchwork. This could pretty much be your final product, right? Uh, what are the benefits? It's very fast and it's very cheap because products are already out there. You just have to put them together, correct? So you need a very good amount of system thinking. You need to be able to imagine how exactly systems work together. So you need to have that kind of a understanding. But beyond that, it becomes very, very easy to actually get moving, right? What are the limitations? It has very limited functionality because effectively what you're doing is you're just patching things together, correct? And you're limited by whatever softwares you're patching together, and there's a good chance that they're not very consistent. They don't work very well. Their languages might be very different in the sense the terms used and etc. things might be not very smooth, very similar. But still, for smaller projects, at times it actually makes a lot more sense to just patch things together, put it out, get some customer feedback, and then you work on it. Then there's licensing problem, which is freeware, shareware. Even in open source, for example, there are different licenses, and those licenses can cause you a lot of trouble, right? Uh, we did speak about Kanban. We did speak about Scrum, but Scrum, in a nutshell, is Scrum is a agile ritual, you can say. So in the agile methodology, um, because the idea is to just keep shipping as fast as possible, um, there's a good chance that the communication can break down if active engagement is not taken care of, right? So in Scrum, what you do is essentially you have a time boxed sprint. Okay, that within 7 days, this is the work that we are committing to, and will attempt to fix. We'll attempt to solve this the entire task in this 1 week sprint, right? So work is pulled through the system in batches. That is a Spring backlog. So you create a Spring backlog that for this week we're going to produce or we're going to work on this 7 items or 8 items or 70 items. Um, you do not allow any changes in the mid sprint. Once you have committed, once the entire team has committed to the 7, 8, 10 n number of changes, middle of the sprint you don't change anything unless there's something massive that has happened. You don't change any the change within the during the sprint. So it works very well, as you can imagine, Scrum, where you can actually produce the work, uh, or your work can be prioritized in batches that can be left alone. So you can produce in batches. It's a batch delivery. So a batch has been created. Now we are just working on this batch. That's it. We are working on this batch for a week, 2 weeks, whatever it is. And only once this entire batch has been processed, that is when we go to work on anything else. Correct? And that is why there is a concept of velocity. So number of the amount of work that you're able to produce per per unit of time. Correct? So Scrum is defined like that. As against that, Kanban doesn't have any kind of prescribed rules. Scrum has a predefined role of Scrum Master. A lot of times, product manager himself has to take care of this of being the Scrum Master as well. Kanban doesn't have a prescribed role, okay, and it also believes in continuous delivery instead of time box sprints, right? Scrum believes in let's batch up some of the work which are related, and let's just work on these 7 or 8 items which are top priority, and let's just ship them out. While Kanban believes in continuous delivery, we should be continuously delivering, we should be continuously producing more features. And because, as I said earlier, it was based on assembly line, and assembly line doesn't believe in batches; it believes in uh, continuous delivery, right? And work is pulled through the system in like piece by piece. There's a single piece flow. It is not a batch flow, and changes can be made at any time because there's only one item which is moving from left to right. Correct. And the way to measure a Kanban is actually cycle time. How long does it take for a single piece of item on an average to move from the leftmost column to the rightmost column, right? And then finally, it's much more appropriate in operational environments with a high degree of variability in priority. So if you have just no idea what will be top priority, what will not be top priority, just use this. Very simply, just use this. It's very difficult to prioritize, right? So why so many? And I mean, I'm just covering the top few. Okay, why so many? Very simply, choices are good, right? The choice. I mean, if you have more choices, it's pretty good. The choice of model depends on the project circumstances and requirements. What exactly are you working on? What kind of team you have, and so on. So you do not have to marry to a uh, single model. You can choose many different models, but yeah, the cost of context switching and people getting used to a certain model is also very high, right? So a good choice of model can result in vastly more productive environment than a bad choice, right? And typically, like I just said, a cocktail of models is frequently used in practice to get the best of all worlds. And models are mixed and match, and all sort of things that happen. But making a conscious decision that this is the model that we're going to follow, and getting all the developers, designers, everybody to commit to that model is very important. So what's the best model? Well, you need to consider the task at hand, the risk management, how risky the product is. For example, let's say uh, you are the guy who has to design the brakes for a car or for a bike. Would you use agile where you will just ship something minimalistic? There's a good chance no, right? You want a waterfall kind of a approach where you have very thoroughly tested something. In agile, you don't. There's a good chance you have not tested it and you just brought out that, hey, I made a break, would you like to test it? There are lives involved here, right? So the risk management has to be uh, really, really good, correct? And the quality, the cost control, the predictability, the visibility of progress, customer involvement, feedback. There's so many things against which you can actually choose the right model. Typically, this decision is left with the engineering, but you need to know what you're dealing with, and that was the entire idea of explaining all of these models. That if the engineering team has decided that we are using this version of agile model, or this variant of agile, or this variant of Kanban, you need to know what you are working with, right? If it's Kanban, can we really produce? Do we have visibility of priority across our different features and requirements? If yes, then why are we not using Scrum? Why are we using Kanban? A lot of people actually use Kanban plus Scrum. So they will create a backlog, and then when you are executing the Scrum, they'll use Kanban, which is also called Scrumban, right? So you can be very creative here, right? The idea is, end of the day, just aim for good, fast, and cheap. But you can't have all three at the same time. So you'll have good and fast, you'll have good and cheap, or fast and cheap, whatever it is. There's a small table that I've created, which compares the various factors against waterfall, V-shaped, evolutionary prototyping. I've skipped some of them, but I think this is pretty well documented, so it should be easy for you to find it online. What works where? I think there's a table that you can use as a reference, right? What's the best SDLC? Uh, it's a Just think about this, and that will help you. I just spoke about the first example, a system to control anti-lock braking in a car. If you're designing this product, what do you think will be the best model? I can tell you the agile model will not be the best model for sure, but it's worthwhile to think which model would you like to use. Then a hospital accounting system that replaces an existing system, right? If there's an existing system, there's a good chance, one, assuming that the only reason why an existing system is being replaced by a new one is because of the age. If it's too old, it was built in a legacy stack, so it's difficult to find new developers to maintain the system, and that's why it's being upgraded. In that case, there's a good chance that the entire functionalities are going to remain the same. In which case, the requirements are set, and you just need a waterfall model. Just go ahead and just do it, correct? But if the models are changing, the requirements are changing, or after the uh, initial phase of where the entire existing system was replaced completely, and then the maintenance time, maybe agile can be used, right? And an interactive system that allows airline passenger to quickly find replacement flight time from terminals installed at airports. I'll not answer this. I will let you guys answer and discuss with me, right? So to conclude, there are too many software development lifecycle models, and in fact, the ones which I just shared, they're not used alone, or they're not used exclusively. They're typically used in mixed with each other. Okay, so I don't think there's any purist approach to this. There are purists out there, but yeah, there's no purist approach to this. Effectively, whatever works best for your team, for the problem at hand, that is what matters the most. And typically you'll not be the one who will be taking these calls. It'll be the engineering team who will be taking these calls, and but you being a product manager, you can always contribute and figure out what works best for the kind of product or the kind of project that you're working on. That's it for now. See you in the next session. Thank you.